Hi guys, this is lesson 8.4 and it is called Special Products. So the word products means multiply, so we're going to be continuing our conversation about multiplying polynomials, and we're going to talk about three specific incidents that just always create a pattern that it can give you some shortcuts, and also it'll help us when we start factoring, which is the opposite of multiplying and expanding. The first example, I'm going to list them and then I'm going to talk about them. So the first one is called square of a sum. And this one is when we take a plus b times a plus b. So that would be the same as a plus b squared. And what's going to happen is we are always going to have this. We're going to go over this specifically, but I'm just going to give you the foundation to start with. The second thing we're going to talk about is the square of a difference, which is really exactly the same thing. I don't even like to think of them as two different things, but we have a minus sign involved. So we're going to be doing a minus b squared, which is the same thing as a minus b times a minus b, and then when we get the answer, it's always going to have this pattern: a squared minus 2ab plus b squared. And then the final thing we're going to talk about is probably the most important pattern to remember, and it is called the product of a sum and a difference. And this pattern is always going to look like this: a plus b, and then we have exactly the same thing except we have a minus in it. And when we multiply this out, we are always going to get this. We're going to talk about this in just a second. But when we start factoring, which is just doing all of this backwards, for example, we would see something like this, and factoring means we would take that backwards to be something like this. When we start factoring, we see something like this. We're going to need to recognize this square minus a square, and then we'll be able to factor it back into that. So I'm just trying to preview why these patterns are important. Okay, now I'm backing back up. Those things are in your notes. So here is the square of a sum. So here's example, we'll call this example 1. And we're going to be multiplying 3x plus 5 squared. When I have 3x plus 5 squared, it is actually 3x plus 5. And anything squared means we're multiplying it times itself. And if I wanted to demonstrate this using FOIL, it would look like this. 3x times 3x is 9x squared. 3x times 5 is 15x. 5 times 3x is 15x, deja vu. And 5 times 5 is 25. Now notice I used FOIL, but I'm expecting that you know what I'm talking about from the last lesson. What happens next is that we see that this, the outer and the inner, we're exactly the same. And so we're just going to have the outer and the inner times 2. And so we're going to end up with 9x squared plus 30x plus 25. So here's where the pattern comes in. What we can see is that in the beginning we had 3x, and that will become 3x squared. 3x squared is the same thing as 9x squared. And then we saw on the end that we had 5, and it's going to be on the end as 5 squared, and 5 times 5, or 5 squared, is 25. And then what happened in the middle was we had the first term times the second term, so 3x times 5, and because of the outer and the inner, that happened twice. And so with 3x times 5 is 15x, and 15x times 2 is 30x. So there's a little pattern there. I don't have to use FOIL. I can just anticipate this pattern. What usually happens with me is I forget the pattern, and when I haven't done it for a long time, and I revert to using FOIL. And as I'm using FOIL, I go, oh, look at that. I forgot about this whole middle term that gets doubled, and I forgot about the last term just being squared and the first term being squared. It's not that important that you remember this particular pattern all the time. You can recreate this idea. It will just make your life a little bit easier if you can see it. Most importantly, I want you to look at the patterns and see things that are happening. All right, the second one that we were doing looks like the same thing. This is back here. We're going to call this the square of a difference instead of the square of a sum. And I don't even really work that hard to think about these as being different. I'll show you why. If I have 2x minus 5y squared, that's the same thing as 2x minus 5y times 2x minus 5y. And if I want to use FOIL, I can. I will go first 4x squared outer minus 10xy inner minus 10xy, and last, negative times negative gives me positive. 5 times 5 is 25. Y times y is y squared. And then again, we're going to end up with our outer and our inner adding together. So we have 4x squared minus 20xy plus 25y squared. So here the pattern happens again. When we have this 2x minus 5y squared, we see that the first term, 2x, becomes this. We had 2x and we squared it. 2x and then squared is the same as 4x squared. And then the second term was 5y, and we find out that that gets squared over here. 5y squared is going to give me 25y squared. And then the outer and the inner, being exactly the same, are going to be both negative, minus 2 times our outer and inner are just the two terms multiplied together. So we have 2x and 5y, so we have the 10xy. And I just remember that because I'm adding those together, they're going to be negative, and so I'm going to have minus 20xy. So you can see this pattern happening. You can practice it. You can reinforce it by just using FOIL. Let's look at maybe just a couple of quick examples. So try this. Make sure you pause the video, and then you can start it back up. So you're pause it about right now. So I'm actually going to use the pattern here instead of using FOIL. So in this pattern, what I'm looking at is I'm going to square the first term, and that would be 8 times 8, which is 64, and c times c, which is c squared. And then I am going to square the second term. 3 times 3 is 9, and d times d is d squared. And then in the middle, there's just a plus sign, so I'm going to have all plus signs. I'm going to multiply 8c times 3d, which would be 24c D, and then I'm going to multiply that times 2 for the middle term. And so I'm going to end up with 48CD, and then I have the answer. If I want to, I can go back and check that with FOIL. Let's try one with a minus sign in it. Let's try 6p minus 1 squared. All right. So I'm going to look at the first term. I'm going to square that. 6 times 6 is 36. P times p is p squared. And then I'm going to look at the second term. Negative 1 times negative 1 is plus 1. And then I am going to multiply 6p times the 1. That would be 6p. And I'm going to times that times 2. And then there's a minus, so I'm going to put that minus in there. If I wanted, I could do 6p times negative 1. So that is actually going to be negative. And then when I multiply that times 2, that'll give me the minus to put in there. So that's probably a good way of thinking about that. This is going to be 12p. And I have 36p squared minus 12p plus 1. So, fun examples. I know you need to practice that some more, but I'm going to move on and show you the last concept. The last concept is called a product of a sum and a difference. And so it's the a plus b times a minus b. So what we're going to notice is, so this is actually example 4, but we'll just call it example 3. Whatever we have here, we have exactly the same thing, only with a minus inside. And so what I want to show you is what happens when we actually use FOIL on this. So here's FOIL. First, 2x squared times 2x squared is 4x to the 4th. Outer 2x squared times negative 3 is minus 6x squared. Inner 3 times 2x squared is plus 6x squared. And then last is 3 times negative 3, which is minus 9. When you have this pattern where you have exactly the same numbers, only there's a plus and there's a minus, they always create this situation where the outer and the inner cancel each other out. So negative 6x squared plus 6x squared is 0, and it just goes away. It's really nice. And then we have 4x to the 4th minus 9. So this is that pattern where I had a plus b times a minus b, and in the end I'm going to get a squared minus b squared. Something to be training yourself to look for is that everything here is squared. So 4 is 2 times 2, x to the 4th is x squared times x squared, and 9 is 3 times 3. So we call this a difference. Difference means subtraction of squares. It's a difference of squares because this is a square, and this is a square, and this means difference. The reason I want you to be looking for that is, remember, we're going to do this in reverse when we do something called factoring. So this pattern you need to memorize. It is one that when you get to this situation, you're going to just need to be able to recognize it, and you're going to need to be able to put it back into this form right here. Let's do a couple more examples. Let's say I have 3n plus 2 times 3n minus 2, and I want to use the pattern. So what I'm going to do is I'm going to know that this one times this one is going to happen, so that I'm going to have 9n squared. I always have a minus. A plus sign in the middle of two squares creates something with imaginary numbers. You will not have that situation this year. And then my outer and my inner are going to cancel. If I wanted to look at that, it would be negative 6n and positive 6n. They're going to come together and cancel. And then there's 2 times negative 2, which gives me minus 4. And so I can just do the answer just like that. Okay, let's do this one. 4c minus 7d, and then definitely pause the video and try this yourself. 4c plus 7d. I'm recognizing that I have exactly the same numbers, 4c and 7d, and one is plus and one is minus. Whenever one is plus and one is minus, I'm going to end up with this situation where the outer and the inner cancel. In this case, I would have 28 CD and negative 28 CD, which would make 0. So I'm just going to take the first term. 4C times 4C is 16C squared. Keep the minus every time, because I'm going to have negative 7D times negative 7D times positive 7D, which is negative 49D squared. All right, because this one is so very important, I'm going to show you, well, I'm going to have you practice one that's maybe not quite as difficult. Those were actually pretty complicated with different variables and stuff. So what if I show you this? Turn off the video, see if you can do it, and then turn it back on. I'm going to have u squared, and I'm going to have minus, and I'm going to have 3 times 3 is 9. So pretty nifty. And again, just going to back that up for you by showing you FOIL. U times u is u squared. U times negative 3 is minus 3u. 3 times u is plus 3u. And 3 times negative 3 is minus 9. So notice what's happening here. That makes 0, and I just have u squared minus 9. What I'm going to want to be recognizing is u is squared, and 9 is a square. It is 3 squared. So in your mind, if you need to practice up your perfect squares. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. Practice those. You need to have them like right there in your brain. I'm going to go ahead and wrap this up, and let me know what questions you still have.